Hello my students, how are you doing? My lovely students, today I am going to review another subject. Please open your book, page 149. Subject Solar Features. The Sun has several features visible at different times at or near its surface. Number 1. Granules. What are the granules? Bright spots. What are the granules? Bright spots on the photosphere are called granules. Bright spots. Bright spots on the photosphere are called granules. This is granules. Granules. Granules are the tops of columns of rising gases in the convection layer. Darker areas between granules contain cooler gases, dark spots called sunspots. Sunspot, what is a sunspot? A dark spot on the photosphere of the sun. A dark spot on the photosphere of the sun. A dark spot, a dark spot, a dark spot on the photosphere of the sun. Do you remember? I asked this question before in class. Why sunspots look dark? Why sunspots look dark? Do you remember, my pupils? Why sunspots look dark? The answer this question is that because they are cooler than the rest of the photosphere. Because they are cooler than the rest of the photosphere. Sunspots have between granules. Sunspots have between granules. Sunspots have a dark spot because they are cooler than the rest of the photosphere. If you could see them by themselves, they would actually look very bright. Scientists have observed sunspots for thousands of years. In the past few hundred years, they have recorded the number of sunspots observed each year. Scientists noticed that the number of sunspots increases and decreases over a period of about 11 years. This is called a sunspot cycle. Sunspot cycle. Sunspots can produce solar flares. Solar flares. This is solar flares. Sunspots can produce solar flares. This is solar flares. Solar flares. What are the solar flares? These are brief bursts of energy from the photosphere. These are brief bursts of energy from the photosphere. Much of the solar flares energy is. Do you remember, my pupils? I asked this question before in class. What are the three waves from the solar flares release? What are the three waves from the solar flares release? Number 1, ultraviolet waves, radio waves. Number 3, X-rays. Number 1, ultraviolet waves, radio waves. Number 3, X-rays. The energy is released, a fast-moving stream of particles is thrown into space. These particles are called the solar wind. Solar wind. Do you remember this picture? Solar wind, a fast-moving stream of particles is thrown into space. These particles are called the solar wind. This is the definition of the solar wind. Do you remember, my pupils? Another question about this subject. Do you remember, my pupils? I asked this question Before in the class, wow, what happens when the solar wind reaches Earth? What happens? The answer of this question is that number one, magnetic storm. The particles can cause number one, magnetic storms, number two, storms disturb compasses and energy, number three, communication systems. Some features similar to a solar flare is called a solar prominence. Some feature similar to the solar flare is called solar prominence. What is a solar prominence? A solar prominence is a bright loop or sheet of gas in the corona. Solar prominence is a bright loop or sheet of gas in the corona. My pupils, do you remember this question? What are the visible features of the sun? Very important this question. What are the visible features of the sun? Number one, granules. Number two, sunspots. Number three, solar flares. Number four, solar wind. Please try to pay attention. This subject is very important. This question very important, and our definition is very important. Please watch this video about solar features.
Hi guys, welcome to another quick review. In this quick review, we're taking a look at the different features of the sun. Now, we said the sun was made up of these two gases, okay, and that was the hydrogen and helium. And at the center of the sun, the core, that's where nuclear fusion takes place. But because there's so much heat and energy and pressure in this core, the material is not a solid nor a liquid or a gas. It's something called plasma. So the center is a plasma, and the Earth has a solid core. So because of that, we have two distinct poles on the Earth. We have the North Pole, on the Earth, and that's the North Pole, and that's the South Pole. Because the sun is made of this plasma and gas, it doesn't have the same amount of poles that we have. It actually could have up to millions of poles, or even one pole. And that's because it has huge twisting magnetic fields. And these twisting magnetic fields cause the energy that's being released by the nuclear fusion in this core to become, I guess altered or changed. Not changed or altered, but maybe look differently. It causes these features on the sun. And the first feature I want to draw your attention to is called prominence. If you look over here, we have this big arch, and prominences are big arches of solar energy. Now, what we have here is a magnetic field line, and this line reaches out, and what happens is we have all these charged particles that run along that field line, which creates this gigantic arch. It's actually big enough to pass the Earth through. Earth could actually go right through this arch. And then down here we have a big blast of energy. So this big blast of energy we call a solar flare. So down here we have a big blast of energy that's called a solar flare. And then you may see, and I'll create one on this picture. Okay, you may see little dark spots in the center, well, not in the center, but on the sun. And these dark spots can appear all around. And we call these dark spots sunspots. And what's happening in the sunspots is that these magnetic fields that we're talking about are so twisted and twined and bundled up into each other that light's not escaping. Well, not as much light is escaping from this area. So it makes it appear that they are black spots, that no light is leaving at all. But it just appears dark because the light around it is so much brighter than the sunspot. So if we were to take a sunspot and move it into space and look at it, it'd actually be much, much brighter than the amount of light that the moon produces for us. So magnetic fields, you have all this energy trapped of course you got to get rid of it somehow, and that's what happens, and that's how solar flares occur, because once it gets twisted, there's a big explosion, and all this energy is released in this solar flare. Okay. So we have three main features that we're learning about are the prominences, which are the big arches, so it's a big magnetic field arch, and all we have this energy over it. Then we have the sunspots, which is areas where the magnetic field is so twisted that it prevents some of the light from escaping. So it appears dark, but it's really not. It's just dark in comparison to the area around it. And once those sunspots become so twisted that they eventually need to release that energy, and we get a giant solar flare, which we have down here. So thank you guys for tuning into this video about the features of the sun. And catch our next video about the layers of the sun later on. Hi guys.
Please watch another video about solar wind.
At NASA, or 241 kilometers per hour. Now imagine another kind of wind with an average speed of 0.87 million miles per hour, or 1.4 million kilometers per hour. Welcome to the wind that begins in our sun and doesn't stop until after it reaches the edge of the heliosphere, the solar wind. The corona is the sun's inner atmosphere, the brightness that can be seen surrounding an eclipsed sun, and home to the continually expanding solar wind. Right now, the Parker Solar Probe, a NASA mission launched in 2018, is orbiting the sun and will get as close as 3.83 million miles, or 6.16 million kilometers, of the sun's surface. Parker is gathering new data about the solar particles and magnetic fields that comprise the solar wind. More specifically, two of its main goals are to examine the energy that heats the corona and speeds up the solar wind, and determine the structure of the wind's magnetic fields. While many theories describe the solar wind's history, this is what we do know. The solar wind impacting Earth's magnetosphere is responsible for triggering those majestic auroras typically seen at locations close to our north and south poles. In some cases, it can also set off space weather storms that disrupt everything from our satellites in space, to ship communications on our oceans, to power grids on land. Nikki Fox is the Division Director for Heliophysics at NASA headquarters. She explains in more detail how the solar wind disrupts our magnetosphere. As the wind flows toward Earth, it carries with it the sun's magnetic field. It moves very fast, then smacks right into Earth's magnetic field. The blow causes a shock to our magnetic protection, which can result in turbulence. NASA also has another reason to study the solar wind and its properties. The solar wind is part of a larger space weather system that can affect astronauts and technology. As Fox notes, we not only have to ensure our astronauts are protected from the harmful effects of radiation, we have to protect our equipment too. So we've already found aluminum to be a good shield to protect our crafts from many energetic particles. But there are also faster particles that travel at 80% of the speed of light, which can cause havoc with parts of a spacecraft. They can smash into and damage solar panels, disrupt electronics, or affect electric currents that flow along power grids. So we're currently
Okay, my students, it was a useful lesson. See you again soon. Goodbye.